When you develop notebooks, I recommend you to use versions in the notebook's names. You will have the file cached already, so it won't take much time for you to read it. And this helps me to organize notebooks in some logical order. Say true here and rerun the cell, and the cache is overwritten. Hello guys, this is the next video related to patterns and best practices that you can use in Jupyter notebooks. This one will be related to how you can work with data, how you can optimize this work, and how you can organize shared work on a notebook with your team, and what patterns can you use to simplify that. In the previous videos, I have already spoken about the value of patterns that you use in notebooks. I won't repeat it in detail. On high level, it's that you will reduce the number of mistakes that you do in the code and in data interpretation. Yeah, as previously, I have created the notebook that will help me to demonstrate certain things that I want to share with you. And third thing that I find pretty easy to follow and which is super helpful is that I store data in a separate folder. So if I have a notebook, I usually put data in a folder which is called data and located in the same folder that my notebook is, and it contains either files directly or subfolders. And in the code, I usually organize it like that. So I have a variable which I usually call cache dir. You can call it whatever you want, but yeah, I use pathly path for that. And then in the same block, I just make sure that this folder exists. If it doesn't exist, then it will be created. And then when I save something or read some cache data, I read it from this folder. Sometimes people put files directly in the folder with the notebook, which is not that convenient, and will make it harder for you to understand where is the code, where is the data, and if there will be multiple notebooks, there will be even a bigger mess. So that's first advice. Then I want to show you the cache pattern that I use in the code, and it consists of several pieces. So first thing that I usually have these cache dirs that I have already shown you. Then I have a variable named override cache, which means and configures if I want to override the cache or I want to read the cached value if it's present. So I have this global constant here, which allows me to toggle this behavior for entire notebook. Then I have a cell where I need the data. First thing that I do is I define the variable with the path to the cached file. In this case, it will be like that. Then I check if there is a cached file already. So if there is a file present and I don't want to override the cache. In this case, I read the cached file. I print information about I'm reading it. In your case, you can just do login info or login something which corresponds to your logic. But the main thing is that I just reuse the same piece of code here with a different variable, with a different file, but with the same structure. And if file doesn't exist or I want to override the cache, I do the actual reading of the data. So in other cases, it may be some SQL query or some other query. I may also move it to a separate function if I want, because this is a custom logic which differs from data point to data point. And then once I have read it, in this case I'm just reading some data from internet, and once I have read it, I say that I'm caching the file and saving it to Parquet. So next time, if I will rerun this notebook or this cell, and if the cache file is present and if I don't want to override the cached file will be read. All right, so I will show you what it looks like in reality. So I will remove the cached file, and then I will rerun this notebook. So first time, yeah, it reads the data and says, okay, caching that. And then if I rerun the cell, it reads the cache file. And if I restart the notebook, which may happen just because you have restarted it manually or because your server has died, so several things may happen, you will have the file cached already, so it won't take much time for you to read it. In this case, in the demo example, it's read pretty quickly, but in reality there might be queries that are executed during hours or even more, so in this case you will benefit from cache. And if I want to override the cache, then I just say true here and rerun the cell. and the cache is overwritten. So quite simple. And I want to show you some improvements in this pattern that you can use. One is that input might be different. In this example, names might be different from run to run. In other examples, SQL query might be a bit different, so you may want different dates or different, let's say, IDs of users to be displayed. And in this case, what you can do is you can put some custom part of the query into the name of the cache file. So in this case, I have names, and then I order and normalize them, because in this example, it doesn't matter if the name is written from a capital letter or from a small one. And then I convert this array to string and put this string in the name of the cache file. And then when it will be read or saved, I will have names with all the names listed here, which works pretty good if you have a few parameters to customize, or if parameters are just in array and not in the complex structure. Though there is one more improvement that you can use in case you have more complex configuration of the query. So what you can do is you can use hash in this case, and I have this snippet of code that can calculate hash for any object that can be serialized to JSON. And I have this also published as a gist on GitHub, so you can just copy it and reuse. Feel free to do that. What it basically does is it converts an object to JSON and then calculates a hash of this JSON object and returns it. And you can either get bytes, like byte string, or just usual symbolic string. And you can use it to calculate hash from some custom part of your query, for example, from a SQL query directly. And as a result, you will have things like that. So hash for some string will be like that. Hash for long string will be of the same size, and hash for the same string will be the same. You can also calculate hash for an array or for a dictionary or for a more complex object. And then if you have this custom part of your query, you can calculate hash of it like that. And then you can put hash in the name of the file, and it will look like that. And if you will customize it or change the names, it will have a different hash. And if you have a more complex query, then of course hash will represent that. That's it. So this pattern is super powerful, and if you will combine caching plus hashing, you will have an ability to easily cache all the data that you use in your notebook, and you can also customize this should override cache thing so that you can override cache anytime you want. Okay, let's move forward. Next advices that I want to tell you about are related to notebook files organization. So a pattern that I use is this numerical prefix in the beginning of the notebook file, and I usually start them from 0, 1, 0, like 10. Next one is 0, 2, 0, like 20, and etc. And then if I need to add something in between these notebooks, like some pipeline part is added later, so I just add, for example, 011 11 notebook or 015 if I want to keep space between the notebooks, so that I don't rename the next notebooks and I have space to add more. And this helps me to organize notebooks in some logical order, so that I and other team members will see, okay, this is usually run first and this is run later. If you have only one notebook, it's not a problem, but if you have several, like 2, 3, it already makes sense to use these prefixes. And if notebooks are added over time, the structure will already allow you to reflect this sequential order of the notebooks. And one more thing is that when you develop notebooks, I recommend you to use versions in the notebooks names so that you will reflect iterative improvements in the notebooks. And I usually do this like that. So if I develop the first version of the notebook, I name it like version 1. And then once it's developed, I duplicate the notebook and create version 2. And then I just move version 1 in a folder that I call archive. You can call it whatever you want. So it looks like that. So I already have it here. So I will just do move and move it here, so that I will keep an old version at least for some time, and if I would break something in version 2, I will be able to get back to version 1. Pretty same thing can be achieved by storing notebooks in Git, though having these suffixes for versions has one more benefit for shared usage that I will show you later, that you cannot get out of Git. Okay, so I've told you about prefixes, suffixes, and backups. Yeah, then you basically can store notebooks in Git. I won't speak about it in detail now, because I have a separate video about Git, and you can watch it and see how what you can do to store notebooks in Git. Basically, what I do is I just clear outputs and commit notebook, and then even code review is possible in this case. Then you can, if you have a notebook that you host on the shared server and multiple team members use this notebook, it's not efficient, and actually it's not actually possible to use the same instance of the notebook. So if one team member will run this notebook and another one will also run this notebook, you will have a collision, and the Jupyter server will tell you like, okay, the version on disk is modified, what should I do? So what we do in this case is we create copies of the notebook for team members like that. And I work in this copy. Another team member will create a copy for himself or herself and add his or her name here and work here, right? So we'll have separate instances, and in order not to commit these notebooks and for them not to just confuse us, we can add them to gitignore in a way like that. I will show you. So you can create a gitignore file in this folder, and then you can just modify it, add a string like that. So ignore everything which has this underscore and then any string, right? And then these notebooks copies will be ignored in your Git client. And if you do these suffixes for instances for separate team members, you will benefit from these versions here, because if you will continue improving the original notebook, and there will be version 3, version 4, at some point team members may notice, okay, I'm working in version 2 of this tool and there is version 4 already, and they will remove or archive their copy and create a new one from version 4. So this version here allows you to, and team members, to keep track of how the original notebook and the tool is evolving over time. Okay, so I told you about that. And one more small and useful pattern is that if you use notebook as a tool and multiple team members use it, you may face a problem of resources occupied. So for example, I have this notebook, I have run it, I have received the output that I wanted, but I forgot to shut down the kernel in the end. So memory resources are occupied. And if multiple team members do that and notebook is memory intensive, then you will consume entire RAM at some moment. And in order to avoid that, you can add this little piece of code in the end of your notebook, which is basically receives a process ID for your notebook process, and then just kills it, and it will do the same thing as you can do by shutting down the notebook and free resources automatically. So if a person will use your notebook like running all, then it will, the notebook will run everything, show the outputs, produce the files that it should produce, and then just kill itself. That's it. So a useful thing when you work with the notebook collaboratively, with a set of tools collaboratively. And that's it for today. That's all the patterns that I wanted to share with you related to data and shared usage of the notebooks. I will post links to the notebooks that I referenced in this video, so you can find them in the description. For now, that's it. Thank you and see you soon.